We are now. Hello everyone. I'm Matt. This is David. We're the organisers of Infracoders. Welcome to Odyssey. I think it's the third or fourth time they've hosted, so they've been a really big part of our community. So thanks to them. This is our February meetup, and we have 3 talks tonight. So we've never done this before, so we're jam-packed full of content. So
we'll be here till midnight or something.
Yeah, so who's a newbie here? Who's first time Infracoders? Quite a few hands, that's awesome. How did you hear about us? Just yell out. Meetup? Everyone's meetup? Who wasn't meetup?
Well, I guess I
Oh, great. Okay, welcome. Yeah, meetup or Aria. Great. Yeah, so first up we've got Simon, who's going to talk about infrastructure from scratch using Puppet. Yep. And then we'll introduce the rest of the speakers. If you haven't been before, normally at the end of all the talks, we'll have a short question time, but also right at the end of the talks, we also have what we call like a community announcements. That's your chance to actually get up and say we're hiring, or can you help me with this problem or something. Just get the community feels back into it.
Yeah, so it looks like we're ready for the first talk.
Yeah. Yep. Right. Simon.
Hi guys. So I wanted to show you a few things that I learned with Puppet over the years. So since I've started it, I had some wins with it and had some fails as well. Had experience with a few different concepts and picked up some wisdom along the way. So just wanted to show you how it all works. First of all, there's quite a number of technologies presented in this talk, so each of them probably worth a presentation of its own. So this is the whole overview of the whole setup, and then in the future maybe we'll get more of a focus talk. So I'm a senior DevOps engineer working at etc. We specialize in application performance management, amongst other things. I come from an operations background, ranging from small digital agencies to a nationwide OpenStack based research cloud, and of course utilizing Puppet where possible to automate infrastructure and processes. So today we're going to model and provision our new infrastructure and establish sort of a workflow to come up with the changes that we make in our development and push to our production. Production is in quotes because it's actually a background infrastructure that we use, but it can easily be a production infrastructure. And also I'm going to present some of the Puppet concepts that's been floating around internet, like deployment with UpNK, roles and profiles, and modeless classification. So what is a big deal about automating infrastructure? First of all, it's consistently repeatable. It removes human error and provisions the infrastructure from defined state. When it is in defined state, you know exactly it will be configured as you define it. You can run the definition on multiple machines and even multiple platforms. It's efficient. So in the past, we've used golden image, manual configurations, custom scripts. All of those are manual and expensive. We probably all experience as soon as the golden image created, we get asked to update it, which is not very efficient and labor intensive. So on the other hand, changes to the code are fairly cheap and easy. All your changes can be validated through a peer review process, and also put through a continuous integration pipeline. We get captured effort, which is all your work is being and provides shared code base, so it unites different teams. And most important one, it's self-documented. So your infrastructure definition in your code base, it validates your systems, and which is also true in reverse, your systems of documentation. So both keep each other up to date and shows you the overview of infrastructure and shows you this is how it is. So to me, modern infrastructure consists of this step. First of all, we have infrastructure automation, which where we get our servers, our hosts from. So in here, I started using Vagrant with VirtualBox. And of course, this can be any other providers like OpenStack or AWS, DigitalOcean, and so on. So Vagrant abstracts virtualization on your machine and just provides you with just enough operating system, so configuration management can take over from there. So I chose Puppet for configuration management, and running with Puppet Board, which is an alternative to Puppet Enterprise Console, which shows you the state of your infrastructure. Then we have deployment automation. Usually, deployment automation will mean deployment of your application onto your infrastructure. But here we're dealing with Puppet. So our application is our Puppet modules. But in real world, besides Puppet, deployment automation could be Capistrano of Fabric scripts and ran through Jenkins, for example. So then another important aspect of infrastructure is logs. Here I'm using Elasticsearch, Logstash, and Kibana Stack. Elasticsearch is used for data store. Logstash filters incoming logs, and Kibana shows those logs, pulling them from Elasticsearch. And for monitoring, I'm using Sensu, which is quite a nice tool for cloudy environments because it doesn't need to, you don't have to edit config files or restart the server when you're adding or removing your nodes. Quite a nice framework. And for Sensu used to have its own dashboard for viewing your infrastructure, but actually discontinued it. So here I'm using Uchiwa, which is another open source tool. So here's an overview of our infrastructure. We have 3 hosts defined in Vagrant: Puppet, Elk, and Mon. All running Puppet agent, NTP client, Sensu client, and Logstash forwarder, which forwards all the logs to our Elk server. Puppet Master will be running Puppet Master. We will be triggering a tool called R10K, which I will explain a little bit more in a moment, to deploy our modules, which are sourced from GitLab. Also using PuppetDB and Puppet Board, as I mentioned before, for viewing the whole infrastructure, all running on top of Vagrant. So to do this, I'm using 2 repositories. One is Vagrant repo that you can
go and see those URLs, and control repo. So background repo contains our node definitions, bootstrap scripts to provide us with just enough operating system so configuration management can take over, and also initial Puppet modules to set up that operating system before Puppet takes over the game. And the control repository stores R10K Puppet file where we define our modules, which I'll show you in a second. Our hierarchy data and roles and profiles manifests. We'll talk about all of those in a second. So for those that can see, the most important is just a tree view of our vagrant repo. Most important thing is vagrant file. Those are our bootstrap scripts that set up our operating system, and the initial modules that we will need. Okay, and this is our vagrant file. This is where we define our host. So this is just an excerpt. We'll see our Puppet master and our elk node. And for those who haven't used Vagrant before, he's pretty much can define all the virtualized aspects of our system. We have host name, IP address, any forwarded ports that we'll want to expose on the host. Here we're triggering our bootstrap scripts and also Puppet as well. Yep. Now the control repo, we have our Puppet file where we define our modules. Again, to install things like Elasticsearch, Logstash, Kibana, Puppet board, and so on. Our data directory contains our variables with hierarchy data, and in the side directory contains our profiles and our roles. Again, we'll go into those in a second. All right, so this idea of Puppet roles and profiles, what do we mean by that? Puppet is all about abstraction. So this is just another layer of abstraction in Puppet code. Resources is the foundation of Puppet language. Each resource describes a component of the system. So it could be a package that must be installed or a service that must be running. Next we have classes, and classes just separated chunks of code, separated manageable chunks of code to manage. Then modules contain an organization of classes, and module could be an Apache instance or a MySQL server, your in-house application that you want to deploy. Then we have a profile, which is a technology stack comprised of those modules, and the role is the represent business logic, which answers one question of what is the host meant to be doing. So the node that we define can only have one role. However, that role can be applied to many nodes. And we'll see more on the modules in a minute. Our data, our module data, is abstracted by hierarchy, which separates our variables from our modules. Because we don't really want to hard code our variables into modules, because that makes them not reusable and not shareable. And all of this is code, so obviously it's version controlled and reusable, and under all those benefits that we saw before. All right, more code. On the right, we have our profile definitions. And as I said before, they just abstract the classes. So you see some classes need customization, like here we're creating some resources for Elasticsearch class. Some we're just putting the class under the profile, and that makes sense. And then with the role definition, we just include the profiles that we defined before. So our Puppet server will be, it's self-explanatory by looking at the role. We have PuppetDB running, we have Apache with WSGI server running to display Puppet board. For our monitoring role, we have RabbitMQ, Sensor server, and Collective client, for example. Okay, so another concept that I want to show you is nodeless classification. And here I'm using the hire include function, which is really, if you don't want to write your own node classifier, this probably would suffice. And this function simply assigns roles to nodes, which we'll see on the next slide. Here we have node default. So this is our side.pp file. Node default will be applied to all the nodes in your infrastructure, and hire include will look up a role variable and include the role whatever is under that variable. So another way of doing that is by doing this, defining each node. But with node default, I think it's better because we don't have to define node by node. It just we're moving the concept of a role into under the hierarchy, which we'll see under here. Here's our role variable, and when hire include looks in under the Puppet, it'll see that role Puppet server is the role for Puppet, which will in turn go back to our side.pp file and include all of the profiles under that role. So on the left, you can see our hire configuration file. And it simply shows where to find the data file for that host. All right, a little bit on modules. First rule of module writing is don't write them. Writing quality modules is pretty hard. There are thousands of modules validated by the community, available on Forge and GitHub. So it's worth to go out and have a look there before you have to write your own. And in here, I haven't written any modules. So I just reuse the modules from Forge and GitHub. So some of the tips that you want to look out for when getting other third-party modules is first have a look at the modules that are written by Puppet Labs. Go for the modules that have lots of downloads and when were they last updated. Do some research on the author and look out for weird dependencies. So some module may not need NTP when you install MySQL. But don't modify them on your own. Submit a pull request through GitHub and do it properly. Okay, so deploy those modules onto our Puppet server. We're using a tool called R10K, which manages our dynamic directory environment. And here, you might remember we had a Puppet file in our Puppet control repository. So each branch in that Puppet control repository responds to a Puppet directory environment. So you can have different versions of modules per your environment, or different modules for your environment. But the only thing to note, it does not resolve dependencies. So you actually have to define each module that you use in your infrastructure. So here's just an example of that Puppet file, where on Puppet Master we have a few modules by Puppet Labs, where we specify the versions. On Elk Stack, we have Logstash forwarder running from GitHub. So just basically show where I think I can find the modules. Okay, so for demonstration, I was going to show you the full stack after I pretty much ran Vagrant up, and that's all you have to do to get this infrastructure going. But I was porting this to AWS today and broke everything. So no demo. But I promise you, the code is available online. It is. This was half an hour ago.
Pull request welcome.
Yeah. those repos, the addresses, you can do git pull, and you should be able to run Vagrant up, and you have all this going. Yeah. So on the to-do list, I want to add GitLab for version control to the stack and Jenkins, so I can get kind of configuration integrate, continuous integration pipeline going. I want to synchronize and deploy the new modules with Jenkins and maybe mCollective. So whenever I do a git push to my repository, mCollective will deploy it to my Puppet Master or Puppet Masters. I want to add some testing, maybe with some like Beaker, which will test the whole of the infrastructure, and also expanding to other cloud providers. So AWS, DigitalOcean, you can just type Vagrant up, and you'll have a full stack running in the cloud. That's me.
Alrighty, so we usually do questions. If anyone's got maybe one or two questions, then now's a chance to ask. But please keep it short because we've got 3 talks tonight. So.
I've got a project which is to use all the output from Factor as a CMDB input. I'm a little bit unclear about what, because I've not seen it done and I haven't really started researching. This is my first been given project. So any suggestions, or have you seen any CMDB based on Factor output before?
CMDB.
Configuration management database.
Right.
Yeah. So
And
we want Factor updating and effectively Factor dynamically updating the push or pull the configuration.
PuppetDB, have you looked into that?
Yes, separate at the moment. It's the form in place of PuppetDB. It works well for us. I don't know have file. The form is an application. It basically runs in place of PuppetDB and stores all that information about the nodes, as well as Puppet locks and things like that.
Definitely looking for forming as well. It's fairly feature rich. You can also use them as a node classifier. So
Yes. So that's pretty much the game, but currently it's Puppet Labs, so it's not supported on the Red Hat 5 series. We need obviously to move up. So fair comments there.
I've just usually used PuppetDB mostly. Pretty good.
If you use any collective, grab backs on arbitrary intervals. So refresh every half an hour for any collective or something.
We'll just write our own interface to what we want to do.
Alrighty, so if there are other questions, maybe we can save them for Simon after Peter comes. So thanks again for that talk. Before you go, while Alan's setting up, I have some giveaways. Puppet t-shirts. Would you like a puppet t-shirt?
Yes, thank you.
Who else is using puppet?
You need to check this.
Have a t-shirt. Who else? That's it. Righty, our next speaker is Alan. Talking about something Docker related, I believe.
Yeah, probably. Just for something different.
Yeah, we haven't had Docker for a while.
For 2015, actually.
Really, first Docker for 2015.
Surely you must have had one in January.
I don't trust that guy. I used to work with him.
Yeah, no, I wouldn't trust you for that same reason.
Too many secrets known.
Oh, I've seen the good, the bad, and the and I'm
Yeah, it's usually doing something.
So, who doesn't have a Infracoders sticker on their laptop? I'll leave them up here. Come and grab them later.
Are they waterproof? That is genuine.
They're fine. They're fine.
How fast? They fade.
Been on the back of my laptop for 2 years.
What's the sun warranty?
Pardon?
For free sticker. Big decisions.
Yeah, but if I'm going to put a sticker on my bike, it's not going to be one that's going to fade that sun. Or go crappy or any of the above.
You can try it and let us know.
Beta testers.
Hey, running technology is easy, hey? So, I'm Alan Harper. I've started at Macropod a couple of months ago. Some of you might have heard versus I've heard before that. But yeah, I've been there for a couple of months and it's been a little interesting challenge because when I got there wasn't really any sort of operations type person. It just kind of happened, but only when something went wrong. So it wasn't the biggest priority. I interviewed to do something else like, oh, you do ops things, and I ended up getting a job created for it. So, whoops. Our existing infrastructure on Cloud 66, which seemed okay. It went off and into the cloud and things deployed, and we didn't really have to worry about it. Except for one little handy day, my colleague did a normal deploy and something blew up. Nobody really knew what. The server was acting funny, so I thought, oh, it's all, fundamental type stuff. We'll just throw away that server and knowledge reappeared. 3 hours later, after we'd noticed it was compiling Ruby, X, some other things like, this is just nuts. At the same time, I'd have new projects coming online, and I've always been a little bit of a fan of Docker and funny. So I thought, well, some of the new stuff coming online, I'll track it in Docker and have a bit of an experiment with a few things. What I like this time is because these were proper 12-factor apps and that there was the app itself and all the things depended on were external. So I could sit there and make a Docker container and get the app up and going. So I've been wanting to play with CoreOS for a year, but hey, this sounds all interesting, whatever. Waste of time, complete waste of time. I found it was good if I didn't want to use web applications or deploy things that actually down. So, nothing critical for a company that does software service like that. So maybe I did it wrong, but I found it was terribly useless.
We'll talk later.
I found the fastest way to learn something that hate you right now. I found the fastest way to learn something is getting in front of as many people as possible, especially in person, and say how something's terrible and it didn't work what you want. And all the answers come along where you come along and say, oh, how do I do this? It's crickets. So maybe there's something I missed, but I'll probably pass it on anyway. So I thought, Fiber, minimum viable Docker environment. Get a couple of instances running Ubuntu, chuck Docker on them, start some containers up. Oh, what do you know? That works all fine. I mean, there's a little bit of setting up by hand and bits and pieces. It wasn't 100% ideal, but the thing is, I had something I knew how it worked. I could roll out new app versions, they wouldn't blow up, and it went all right. So set up something base using Ansible, because I'd been meaning to play with Ansible as well, and last time I played with the chef, I thought, this is getting a bit out of hand. I mean, I work for a small company. I'm quarter of the ops person. So the rest of the time I actually have to go write software. So simple, and it works. I'm fine with that. Got that going. I use my other tool, which I've probably mentioned every other time I've given a talk in the last 2 years, which is BuildKite, formerly known as BuildBox. Really simple for those who haven't heard of it. It's supposed to be a CI service, but really it's a service that runs a shell script when you do something in Git. So in my case, we push something new to Git. We would run the test how did they exist on some of the projects that they didn't yet. Basically after that, we'd go build up a Docker container, put it off the Docker registry, and then there was the third part, which would go SSH to each of the servers. We could say, hey, go run this script, which would basically pull the service down, do a Docker pull on the container, and bring it back up. But at the first step, it was working and understood what was going on, so we could start. But as things go on, I was at the Go meetup of all things, start of January, and a few people were talking about how they're deploying Go apps, and a few people were using Docker in different ways, and somebody mentioned Elastic Beanstalk. I'd heard of it, I didn't realize you could deploy Docker containers with it. So out of the box, you get an environment set up which runs your Docker container in one or more nodes, which you tell it to run automatically using CloudFormation. It sets up ELBs for you, it sets up the RDS, so it's like, all right, here's a bunch of things I don't want to spend time mucking around on, just go and do them for me, and it did. So I've taken the existing build configuration I had, and all I have to do is say, go take this Docker container with this tag, and go make it appear in the cloud. It would take slightly longer, so it takes about a minute to write our Rails apps because it's got to shift around 300 or 400 megabytes of stuff to each server, but it works. I mean, it works reasonably well. I know what's going on to a certain degree. I mean, there's a little bit of black magic, but on the machines that run Docker, but you can still SSH into them, and you can still sort of peek behind the curtain and see what's really going on. Like the surprise Nginx instance that's in the middle that's not documented anywhere. Which only bit me once, like, how is this? I was writing something, I was like, there's no Nginx involved in this. It should be keying straight to the application server. I went looking around like, oh, all right. The little thing I wasn't expecting. The other handy part with having a configuration that lets me specify a tag Docker image is now when we build a container in CI, we only build it once. So when the commit happens, build the container, tag it with the SHA of the Git commit, and then after that, the rest of our deployment steps are make this SHA appear on this environment, and it goes off and does it. So now I've got the exact container that I've built up every online that's running my testing, all the way up to production. It's the exact same thing. So the only thing I've ever mucked up is environmental where it was like, oh, that's fixed. So it's not the end of the world. So it's working reasonably well for me now. Haven't got all of our apps across using it in production yet, but it's the way everything's going, and I know what's going on with it. A few little tweaks along the way from bits and pieces, like I don't know how many people deploying Rails, for example, but the first problem I had is you spin a container up, and as it's building, you do a bundle install. And because all the previous state isn't there when you use Docker, you have to do a bundle install, pull down half a gigabyte of stuff, do some processing, and you'd sit there 10, 15 minutes depending on what's going on when you've done the 2-character change, which was a little bit terrible. The next step is, with the way Docker files are built up, if the previous steps haven't changed, you can skip straight over them. So in this case, when I do the add for the gem file lock, if those files haven't changed, it doesn't add them again. So that means the command after it also doesn't get run again. So all of a sudden, unless I change some gems, that step gets skipped straight over. So that's speed things up to a reasonable amount, except of course if you change a gem, you still have the half gigabyte of stuff downloading. And at the moment at our office, we share a 4G connection between 12 devs. So it's really terrible. Like, we're in the end zone and we're getting it this month, but we don't have it yet, and it's a little bit frustrating at times. So you really don't want to download stuff you don't have to. But once I got this step going, it was better, but it's still that big change is still annoying. So I started hacking things and ran into the limits of Docker files. So in this case, what I do now is using Docker run, I run the bundle install, but I mount the volume from the parent file system. So once the gems are installed there once, the second time I run it, it'll very quickly go, oh, I only need to install this and remove this one thing. So it might need to download a couple of megabytes, but it's fast. Then I go and copy the whole gem set into the Docker container. So the downside is if you've got a lot of gems to copy over, that second step takes a bit longer, but for one of our apps, I found it makes things overall much faster, so just deal with it. It's better. You always want to walk towards better. But the key thing I've learned along the way is you don't want to build apps inside a container, because if there's dependencies getting dragged down, you're just making the container bigger, which means it'll take longer to push up to your Docker registry and then deploy to your nodes. When you with only small changes, you can make it much faster. So in this case, for one of our Go apps, literally we spin up a Docker container which has got access to the source code, install the dependencies needs from Go, and then build the application. Where the output of the application goes to is again mounted volume from the host file system. So we just literally copy the binary out, then we do a Docker build, and we just add that single binary. So a Docker containers, when we deploy them, maybe a difference of 10 megabytes going across the wire, which is reasonably fast in most scenarios. We're doing a similar thing with our Node apps as well. The other handy part of doing this build inside of Docker instead of on a normal CI system where you got stuff set up is we tried upgrading Node.js the other day, and I never liked Node, but it's the necessary evil of what we do. And something broke somewhere, and previously you would have had to figure out how to either rebuild CI machines or muck around. In this case, one of the developers went, oh, well, we'll just downgrade our Node version, which is literally just editing a single file, typing the new version back or previous version back in, or doing a git revert, and it goes back and everyone's happy again. So CI machines don't need anything installed. There's no any Ruby that's installed is one that ships with Ubuntu. The same with Python and everything. That's just what's there. We add Docker and that's it. Everything else runs inside a container. So the first one runs needs to pull stuff over the wire, but I don't care about that. It fixes itself. The other trick along the way is do a bit of analysis of what stuff is in your Docker container when it's being built, because everything that's in the directory or under the directory where your Docker file is actually gets tied up and sent to Docker, so the files there are actually available during the build. So if you've got a sizable repo, you don't need to send the Git directory in there because you've already got all the files. So you skip that. Log directories, temp directories, there's usually stuff along the way that you don't need to copy out. So a little bit of analysis will speed things up a bit, and it's pretty cheap to do. The other thing that really matters is we were using the Docker registry, but it was slow-ish from where we were, so I just set up in a private Docker registry and one of our instances near everything's deployed, and it's made things faster. Yeah. Did you have a question? No? The other cool part that I like myself is because of the way the scripts are written with a little bit of tweaking, we can actually run CI on a developer's machine. We've got Boot to Docker installed, and literally you just run the exact script that the build kite runs, and it will go grab everything it needs, run CI and go, yeah, it's cool. Or no, you've missed this bit again, you moron. But it's easy to run locally, and especially those debugging scenarios where you've got, hey, it passes on my machine, but not CI. So you've seen those Git commit messages, they try and profession, they get shorter and terser, and there's more swearing involved. It's like, it's frustrating when people are in the situation, but sometimes they don't have access to any other ways of reproducing the problem, so we'll try this. But in this case, every time here and at my previous job I've had one of these types of problems, because we can run CI like a machine, just run it, and that cycle time is so much faster that you very quickly get to the source of the problem. It's sometimes something silly, but it's also a nice setup. It was also good at my previous job because we had a lot of parallelization in our test run. So using the CI version of running the test was actually much faster than running things on your local machine manually. That's the short version of it. Anybody any questions? Oh, per machine, yes.
So have you thought about what you're going to next when you have to link containers in that next step?
I don't use the Docker container linking except in CI. Anything else, like if I need to bring in database or something, it's just a URL that's available. Because I'm using RTS, it's on the side. I found the linking, it bugs me a bit for production type situations, and you can't do it across machines yet.
Yeah, so if you're building the application outside of the container or any dependencies outside of the container, how do you ensure that whatever you build is actually reproducible? For example, you do something, and the next day you want to make a trivial change on different machine, and suddenly you're getting a totally different result because that developer had something, say, going on there, but maybe some legacy gems or something from that document, the gems.
It really shouldn't be a problem considering with our Ruby projects, the gem versions are specified. So if they've gone and yanked a gem or something, that'll mess with this, but that's going to mess with the second bay.
Actually, so let's say you remove some gem, but it's still there in the vendor gem directory.
If using bundler, they will clean that up. I'm told the same thing will happen to NPM, but there's been some voodoo there. I can't get straight answers. I'm like, what commands should I run to only have the stuff that's supposed to be there be there? But there's other people on the team who have argued with me, and sometimes they would just blow away the node modules directory. And considering everything's supposed to be versioned, it all supposedly comes back. The real safeguard there is the CI side of things. Once the container is built in CI, we run the tests inside the container that actually ends up in production by linking our databases. Then it ends up in our staging environment. If it's proven good there, that exact container looks in production. So these version mismatches and shenanigans, possibly could happen in a way I'm not seeing, but they really shouldn't happen. Okay.
All right, thanks for that. Next up, we've got Ricky.
More Docker.
More Docker.
Yeah, more Docker.
Don't have too much Docker.
That's right. No, don't put your database in Docker. It'd be stupid to do that.
No Docker database.
Nothing that has state URL. Don't bother. That's what configuration made is for.
Docker and good. All right. So after this, we'll have the community service announcements, and then we'll have pizza. So, ready to go? Over to you, Ricky.
As long as the displays do things properly. But it's not letting search it behind.
Oh. Well, not Core OS, so it should be fine.
Where I beg to differ. With with yeah, well, that's because they shave. Of course, Sam. And
Well, now he's just showing off.
All the technologies.
yeah, that one.
Oh no, you'll have to use a keyboard.
Okay, that's fine. I don't need that. As long as I can get my speaker notes here, I'm good. I'm good. Brilliant. Okay. So yeah, I'm gonna mute that. I can't mute that. Sure, whatever. So I'm Ricky Cook. I work here at Odyssey, and I have been building a tool for the last probably 4 or 5 months or something called Doxy, because I am incredibly unhappy with every single CI solution around Docker ever.
You should try build code.
Pardon?
You should try build code.
Okay. So yeah, 4 months. I think I have something that's pretty damn good. So yeah, I'm going to start by sort of going through a little bit of history, just so we're all up to date on the actual purpose of CI. So basically, the whole purpose of CI for a developer or ops or anyone is to make sure that when you push code, you have a really short feedback loop between you pushing it and your code telling you you're an idiot, you screwed something up. And like the reason behind that is because if you context switch away from what you just written, then it's really difficult to come back and you've forgotten what you're working on. The other thing it does is it actually makes you run tests. So developers are chronic for just not running tests. They're there, they should be run, but actually typing, you know, /run test, a little too hard. So CI automatically makes sure that all happens. It also gives you clean, repeatable builds, untainted by your special kernel improvement that you might be running on your workstation, or your recompile libc or something ridiculous like that that I've done. Yeah, so the evolution of CI has basically gone through several different phases of, hey, that's a good idea, let's start doing that. I think it's really important to sort of understand that transition to see where it's going to go in the future. So basically, started out like you've got people at like box computers with CRTs and that stuff that we don't use anymore. And we had human testers that were entirely doing the whole thing. Now, don't get me wrong, human testers are still totally necessary and do a great job. It's just that they shouldn't be doing the same job every single time that they test stuff, because they're really slow. We invented computers to do repetitive crap really, really quickly. So they shouldn't be doing that. We should be doing that with scripts. So once we actually wrote those automatic tests, we decided, okay, we should automate like running all of them at once. And why not? Like, we know how to code, we can test stuff rigorously, we can automate it, we can just /run test, and that's much better than individually running stuff. And yeah, so there's no point in failing stuff that we've failed before. We know about it, write a test, and it doesn't happen again, hopefully. So why should we run them automatically? Why not? Like, if we've got these tests that all go through the process of testing your software, why not just have it happen? There's no point in now, like, we went from running tests manually, each one, to /run test. Why should we even /run test? I mean, we git push right, or we svn go do things. And that makes you actually run your tests. It's all well and good to say /run test, but then actually doing that, that's chore. So then somebody said, why don't we have a GUI for this? Now, I imagine this person was some sort of a Windows developer. So that makes it easier to navigate. It gives you a nice go button. It's good to show off to managers. Pretty much anyone can hit a job and start a test. There's no real code to build, test, deploy, etc. There's only code for the initial setup. And it can be a really, really basic monitoring, like a ping, make sure this thing works. It's basically a GUI for a cron job, essentially. So then we decided that script tasks behind that go button, that's way too difficult. Like, I can't write a bash script, that's ridiculous. So then someone decided that they needed a GUI to do even the most mundane things. Specifically, I'm referencing things like the command task, which I'll get onto in a bit. But so then we had stuff for Grails, which is a command line tool. Grails, it's like make Grails do a thing. I mean, you essentially have to fill in the same field. It's just in a GUI now. You've got rake, again, like make. It's two fields that you have to fill in. What the hell do we have that for? HTTP post, we have curl. Why do we need that? Start a Tomcat application, ridiculous. SCP a file, come on, what the hell is this? And
what's your better idea then?
Well, that. So, and this is the command task. I mean, what the hell does this do? You select an executable. How about you select it by typing LEIN? You put in arguments, space, environment variables. Well, you prepend environment variables, working subdirectory. There's this great thing called CD that I invented. This is the most useless example of CI in the history of forever. Nobody should ever do this. It's just insane. So that's sort of my rant on GUIs in CI tools. Oh, yeah, that's to remind me that that command thing is ridiculous. You are done, see? So then we came to like a scalability thing, and CI became an orchestrator, like a deployment type thing. You press a button, grabs all of those artifacts, it goes and it pushes it out, and it maybe does some SSH and it runs some things on your servers. We've got Puppet, you might run a Puppet run, who cares? So yeah, the problem with a GUI is you can't git control it. It's good for managers, it's good for people who don't code, but I mean, your CI tool is for people who can code. Why do we really care about people who can't code except to show them if it works? So you can't git controller. It means it's not tied to a version of the code, which I'll talk about a little bit more later, and it's not part of your code workflow. We've been coding for a really long time, and we've come up with some pretty fantastic workflows around working with text-based stuff. We have not come up with good workflows around working with GUI-based stuff. That's why Puppet for Windows is not so great, because it requires GUI stuff. So it's difficult to automate, especially when it's like entirely stored in the database. If you've got your if you've got all of your config and all of your script stuff and it's stored in a database, then like what can you do? You can dump out the database, but if you want to start from scratch with just the raw stuff, then you can't really do that because it's got a bunch of other stuff in there. So it's not particularly repeatable when it's in a GUI. So why are we not okay with text and code? We're developers and we're ops. I mean, yeah. Yeah, I mentioned Windows. So there's another problem, and that's build agents. So Jenkins, Bamboo, pretty much everything that's out there today uses this idea of a build agent. And the problem with build agents is kind of the same as the problem with a VM. If you want to scale it, then you've got to start up this whole build agent and you've got to do a whole lot of stuff, and that just becomes a lot slower than just, you know, running stuff locally. And yeah, if it's not on demand, and then you don't tear it down and restart it for every build, then that means that your build agent is going to become dirty very, very quickly. So developers sudo, you know, yum installed whatever, or put their cache files somewhere, and all of a sudden you've got later builds that are tainted by your previous build, so they're not clean anymore, which is kind of one of the really big things with CI. And an agent has the kitchen sink included, so it's not like your prod environment, which you're essentially trying to test that your software will work on. It's now some special snowflake extra thing that looks nothing at all like your prod environment. So yeah, it doesn't look like anything real like the real environment. There are a lot of issues with them. So today's CI server, we've kind of progressed beyond that that big agent type thing. Like we've got Travis now, for example, which is sort of a in the cloud type thing. You do everything in, like, you configure it in a YAML file. Other than that, you click add GitHub, and that's all the configuration you do. That's stored in Travis at least. So there's kind of two types of CI server now. There's a CD, the continuous deployment build server for building up artifacts. And then there's the task runner type thing where you click a button and it goes and runs some stuff. And Jenkins is mostly okay as a task runner, or you could just use mcollective, it doesn't really matter. But yeah, Jenkins is mostly okay for task runner or Bamboo or whatever you want to use. But as a continuous deployment type build server for building artifacts, then you've got all those problems that I mentioned before. So Travis and Doxy are both the continuous deployment type build server for testing, building artifacts, that sort of thing. So yeah, Travis stores all of its config in a YAML file, which means that if you want to modify the build config, then you do a pull request, exactly like you do with any other code. If you want to change how your tests run, you modify a YAML file, you commit that YAML file, and all of a sudden, your dev branch works differently to the master branch. So you can test that your CI config is now going to work. Everything, all of your config now becomes part of your build flow. It's also got huge amounts of GitHub integration. It's really good if you use GitHub. Yeah, but it's not like the deployment environment. Travis essentially gives you an Ubuntu box, which you have no choice about. You have to install all of your stuff, apt-get, etc. I challenge anyone to run Puppet on Travis. That would be interesting, but not recommended. And it can be quite slow. They're not very powerful VMs that they spin up. So yeah. And there's nothing that really tackles like integration. You can't build an artifact and then deploy it back to your private infrastructure. You have to deploy it to some public thing and then, you know, trigger a deployment elsewhere, for example. So there's no deploy on green type thing. And also like actually integration testing. So if you need a database or a custom microservice or something, they have a few, but really they're pretty bare bones, and it's left to you to set all that environment up around your tests. I've already covered that, so I'm just going to skip on by it. So Docker is a platform. Essentially, yeah, it's better for separation of roles and responsibilities. You've got ops that manage platform, devs that deploy stuff to that platform. I mean, there's much less blame. It's really good. It makes it a lot easier to think in terms of HA from the start. So really easy to make a Dockerized app clustered because it's transient and it's got a bunch of stuff. And yeah, it really makes you think the whole adage of cattle, not pets. But everyone starts to think like that just because of the way Docker presents to you. So build and test. Build and test of Docker stuff is not that nice. Most places that I've seen, containers are often built just on dev workstations. They're tested outside of that container, so you might build up a build artifact, but you don't then test that build artifact. You're testing code that's on your workstation. So that's a problem. And CI servers, there are plenty of people that do Docker and CI stuff, but yeah, as I said, I don't particularly like how it works at the moment. So Doxy, which is the first time I've said it in quite a while. So what exactly is it? It's a tool for building, testing Dockerized applications, essentially suited for integration testing in a highly dependent system. It wasn't actually this morning on the train, it was about a month ago, but yeah, it may change tomorrow depending on what I feel like. Yeah, so I essentially wanted to solve the integration testing problem of spinning up a database server, spinning up a custom microservice, spinning up whatever you want around your tests. So the build flow, whoops. Okay. Slow. The build flow for Doxy is essentially you add a new job. So essentially all you do, you click add, put in a job name and the Git repository, can be GitHub, can be whatever, and that's all of the configuration that you do in Doxy. There are a few things like hip chat info and stuff, but that's sort of to the side of the actual build stuff. So then you run the job. When you run the job, this can be pushed from GitHub or curl or whatever you want to do from your revision control system. And all you need to do is you specify a commit ID or a tag and the job that you want to build. So it's a RESTful API, you just push to it and it triggers a build on that commit. So your build gets queued, you allocate a Docker worker, and a Docker worker is just, here's an IP with Docker running on it that I can access. So your agents are kind of still there, but they are really simple and have absolutely no impact on your build at all. So your build starts running pretty quickly. It does a git prepare, so it checks out the commit or tag. It figures out all the git info, like the author, email, any version tags, etc., that applied to it. And the git tags are used for versioning a Docker container, so it's all, again, in Git. You provision the deployment containers, so database, login server, messaging server, whatever you want. It builds a Docker image. So it's just a basic Docker build of the Docker file in your repo. So again, all in all of your agent config that you'll be doing is all in your Git repo.
Hey Ricky, reason is really old. Are these slides going to be available afterwards so that you can see it?
Yes, they will. Yeah, I'll put them somewhere and link them on the meetup group. Yeah. This graph is a little bit small. The code that I've got in the next few slides is real big, so you should be good. So then you spin up an instance of that Docker container that you just built, and you run your tests. It's essentially Docker run CI. It's not configurable. Docker will always do Docker run CI on whatever endpoint. So just so that really simple, you know exactly what's going to happen when something does stuff, and you can run that elsewhere as well. And then you just run your tests inside your application however you want. You collect build artifacts, so Docker will, after the tests have run, it will go and download stuff from the Docker container. which means that you can save those junit.xmls or whatever coverage reports that you want. If you put a version tag on the Git commit that it's just built, it'll push it back to the registry and apply the tag. So your registry, I would assume, would then do some nice thing like, hey, I've got a new versions tag, and then go and automatically deploy it all the way up to prod. Yeah, and then it cleans up the workspace. That's kind of important because you don't want a whole bunch of stuff just hanging around, because then you need to go and manually delete it. So yeah, the basic thing that I was thinking when I did this was you've got your front end that you want to test, you've got a search service and a payment gateway that's using nice new technology, and then you've got a database that does all of your storage stuff. And you need to spin all that stuff up so that you can make sure that your main app still works with the latest version of your search service, because that's a custom thing. Yeah. So I've gone and done this really simple example thing. This is Perl, just because it was probably the most concise language to write a really tiny thing in. Anything longer than this, you should never use Perl. Doxy is Python, don't worry. So yeah, basically creates a socket, and then it listens for connections and it echoes back anything it receives and then exits 0. So incredibly simple service. That's the script that's in and this is the Docker file to set that thing up. So really simple. You set an entry point that wraps around that echo service, you set the locale, you make a directory and you add your code, and yeah. Actually, yeah.
So you're running Perl code with Python?
Yeah, that was my question. With the shell in the middle.
So actually,
Go around the outside.
I did just look at my next slide. They're both labeled exactly the same. I think this is actually the Docker file for my next thing I'm going to show you. But they're essentially the same. It's just that you don't install Python because Perl's already there. So yeah, sorry. This is the Docker file for the next thing, which is the tests. So yeah, so the entry point up there basically tells Docker that just execute this with the CI command. Doxy will do that. And then this is your test. It's in the root of your test thing that you're testing, Git repo. And essentially it just says hello world echo service, which is what we called that previous Perl / thing. Alias echo service, which is a Docker thing that makes you able to connect to it. And you give it a command for Docker to spin it up. So that's how you provision the echo service. You can do the same with any database, whatever that you've built in Doxy. And then your test, again, really simple, connects to your echo service with the alias that you've given it in your file, and then it is a string. Make sure that it gets the same string back. That's the test. So, quick demo. You're all welcome to follow along on your phones and do a load test, because I've never load tested this in my life. So if you want to make a crash,
Because Infracoders has never crashed a live demo before.
no, of course not. It's all going to go fine.
Just spinning up AB right now.
The URL was on the slides that I moved off too quickly.
I see. Doxy.io.
Yeah.
All
So-
the bullshit has a Doxy.
So yeah, ic.doxy.io. Don't go to w. That's my one.
So there's no authentication.
Well, that's what the W dot's for. Nobody can write to it except me. Take that as a challenge if you want. Not until I'm done. But, done. So here's the echo service here. So the configuration for that, really simple. As I said, you give it a slug, a name, which is just the display name, and a GitHub thing. That's all the config that you do. you go and you say, GitHub can go and push this, and it can say the 0.0.1, and you say Q build, follow the logs, and it'll go up. And that's how quick it is to build up an entire like Echo service container thing, much faster than VMs. So as you can see, it's checked out the code. It's got all of my my details from the Git commit. Apparently it has no changes because it's done something wrong. That's okay, it's an alpha. Picked up the Git tag, doesn't need to provision anything, and it goes and does all of this building the container stuff, and then it runs the tests. No tests here, so yeah, and then nothing to fetch. Then it cleans up the container.
What did it say about chickens?
Nobody here but us chickens. No tests. Yeah, so as you can see here, it's picked it up as a version tag thing, and state it's all good, which means that we can use it in our test thing. So now our test that actually uses that thing, we go and say we run, we go ahead, and then we follow that along. And here, as you can see, started up the Hello World Echo Service v0.0.1 as per the YAML file we put in there. So that's now running alongside it. And assuming that Docker doesn't do something awful, or actually I should probably blame my code before I blame Docker, but or it's not. Oh, there we go, just slow. So you can see it's going up and it's building all of this stuff. It's pulling down all its dependencies from Debian. And I will probably, yeah, I'll do something else while it's doing that. But that's a nice streaming log. I don't have anything else to do while it's doing that.
Sing a song.
Oh yeah, so if you want to go on your phones and like go into the with depths thing and forbidden.
That's what happens if you're trying to kill a bill.
Yes, exactly. You can't write to it.
No.
But yeah, so if you go in there and load test it, then
is there a hard dependency on the Docker registry?
There's not. So I can do that while I'm doing this. Where's my mouse? So I see doxy file. So don't worry about session secret. It's not actually secret. It will be in the future, but it's not right now. So you can either use a Docker registry or not. This weekend I will be expanding this so that you can put in multiple Docker hosts. It's all in the back end. I just haven't written the UI for it. How's that been going? Still doing things. It's worth noting that this will all be cached if I had done this before, but there you go. So it's built your image, it's ran one test, it's all good, and it passed because it has the Echo service there on port 7000 I can connect to. And yeah, so go. Pardon? I'm not a front-end dev. My JavaScript is disgusting, so it's written in jQuery and nothing else. Inline scripts. I know I need to change that, which is why my next slide is a call out for any front-end developers that want to help.
I'm pretty sure they use Paint.
You do all of your like pitches to get money with that, don't you, Sam?
It's got a good GUI.
Okay, so that's a quick demo. I don't know how useful that was, but it spun up the service, tested the service, all works, brilliant. So you can test up, you can spin up like 20 microservices, a database, Elasticsearch, whatever you want, whatever custom containers that you want alongside your thing, which has traditionally been, I think, quite helpful. So yeah, I'm not a front-end dev. It'd be great if someone even just sort of went and helped plan like a new front-end framework and I go and then code it, but I have no idea about front-end. I have a UX design guy that's doing stuff, so that material design stuff won't be there. It's going to get much, much better. And yeah, it's hopefully going to be a totally real-time UI with a separate server that handles huge amounts of transactions, that sort of stuff. But I'm not a front-end guy, so hopefully real-time UI is probably going to take me quite a while. So if someone wants to help, that'd be great. And links, I'm going to take down that Infracoders demo thing because it's on an extra large AWS instance. Whereas this is on a 512 meg of RAM droplet from DigitalOcean. So that will crash. I don't care, go nuts, crash it. I can restart it. Yeah, and there are all of the build examples and a link to the project up there, which I'll put on the meetup page. And I'm done.
Thanks for that. Questions?
Yep.
Is Doxy tested in Doxy?
Well, I have that demo.doxy.io, which has Doxy app. So this goes and does stuff whenever I push to whenever anyone pushes to the Doxy repo. So yes, it is tested in Doxy, but I wouldn't really call them tests because this is definitely just a prototype, alpha type thing right now. It essentially does style tests and that it. So yes, but also not really.
You got some reads there.
I do. They are errors when I push a bad commit, which has sort of screwed up the entire test thing. Yep. There are more errors.
What are you going to be doing in terms of sort of team management, access control, that sort of stuff?
Yeah, so that's definitely in my backlog. Whole huge set of things that I need to go do. It's not in there for the beta, but it is user logins that will get into there probably ahead of some of this Icebox stuff. Yeah, I'm also planning on doing a CLI and possibly an add-on for Bamboo, Jenkins, that sort of stuff, so that you can drive it from Bamboo and Jenkins, but have it just drive the log through, so you can use that for your access control. Yeah, I'm not sure which of those things will come first. Yeah. Yep.
When and where can I get it?
Yeah, the GitHub. There is a Docker file in there which will build up a thing. I just haven't Docker pushed it to any registry. But you can clone it. You can do Docker build and then Docker run, and it will work. Yeah.
What immediate problems do you see with it? And it's beta test, like it's beta source for as it is right now. So obviously we're going to provide feedback on it. How do you think it will handle my continuous kernel integration?
So, for those of you that aren't aware, Sam does something mildly insane, and he builds a dev package of a compiled kernel that he does once every half a week or something. Yeah. So they deploy a completely custom compiled kernel. Anyway, so he does that in Docker, which is reasonable. But right now it wouldn't, only because I can only have one Docker host. As I said, this weekend I'll be able to have multiple. Other than that, it will probably do essentially the same thing as what you've got set up right now, which is, you know, build a Docker container, and part of your Docker build process is to compile a kernel and then you pull it out. So Doxy will do that exact same thing. You've got the artifact, so you can pull out a dev package, whatever. But I am specifically thinking of a different way to do libraries, which is you create an image to essentially build, and then you run a command to build and pull out a thing. So you've only got one image, and then it just goes and like builds stuff.
It's like a build environment, yeah, run environment or something.
Yeah, so you create one Docker image, and then you just say build this, build this, build this, and yeah, sort of still in. Yeah. Anyway, so yeah, there is this will work perfectly fine for those non-deployable type artifacts, but I am thinking of another solution which will be more specific to non-deployables. Yeah. Any other questions? Excellent. Thank you very much.